Over the last few years, there's been a real good adoption of the SFI, Sustainable Farming Incentive, and there are lots of people doing lots of really fantastic things with in-field options. So they're using things like legume fallows, herbal lays, cover crops and all sorts of different things, and they're using the action for the short summer fallow mix. But when you actually talk to farmers, none of those options deliver exactly what they need in terms of a year-long fallow. What we found working with the Lens programme in the east of England was that they had a specific year-long fallow action, and that could be a cover crop grown over winter with a break in the early spring that would allow farmers to do other work, followed by a summer fallow. And that's a really practical option that allows farmers a window to control grass weeds, do drainage work, and actually clean up a bit, and actually we believe deliver really good environmental value. So what we want to demonstrate in this project is A, the practicality of delivering through this type of action, and B, the environmental benefit.
So this is a summer fallow cover crop that we've planted for a number of reasons. It's to give us a really good break in the rotation from our usual cereal crops. But also it's biologically feeding through its roots and root exudates the microbial communities within the soil. It's physically structuring with its root system. It's providing a habitat for pollinators as well, and a habitat for butterflies. So here we've planted a 9-way multi-species summer cover crop mix, which is made up of brassicas with things like mustard and oil radish. We've got some legumes, some beans and clovers, and some vetch as well. We've also put some cereals, things like winter wheat, oats, and also some sorghum sudan grass. And then we've filled it out with some sunflowers and some phacelia as well. It's a really good mix for not only the pollinators, but there's a diversity there that's feeding different microbial communities in the soil, and it's providing us a really good above ground biomass.
We've been measuring cover crops, particularly interested in how they work to trap nitrogen, stop it leaching and causing air pollution and soil pollution. We've been measuring soil water nitrogen regularly throughout the season as the cover crops have been growing, and we've been measuring soil nitrogen at the end and the nitrogen uptake of the plants at the end. We've also been measuring soil microbial activity using our micro-REST system. So we're looking at how good the soil with cover crops is at feeding the microbes and the below ground biodiversity compared to bare soil. We've been measuring the soil water nitrogen at different depths using this special equipment called lysometers. They're just long porous tubes that go into the soil and can collect soil water from different depths. We use a syringe on the top of these lysometers, open the valve, and then as we put pressure on the syringe, it causes a suction at the depth and it draws up the soil water after a heavy rainfall. We can collect that and then measure the nitrates in it from different depths in the soil profile. We've been taking plant cut downs and sending those off for analysis of the nitrogen in the plants, and we've been taking soil samples for soil mineral nitrogen. We've been digging soil pits to look at the soil structure. We've been using the VES scoring system, which is the visual evaluation of soil structure. We look at the profile and we estimate the structure and give it a score to see how well structured the soil is in the cover crops compared to the bare soil areas. What we found in this project was that having cover crops decreased the nitrogen in the soil water. As we sampled over the season, there was less nitrogen found in the water underneath cover crops than in the bare soil, because the cover crops were soaking up that extra nitrogen and not letting it leach away in the soil water. When we measured soil mineral nitrogen at crop destruction, we found that there was less soil mineral nitrogen underneath the cover crops, because again those cover crops had been soaking up that extra nitrogen and hopefully storing it ready to release for the next crop. We had a surprising result with the VES scoring. A lower score means a better soil structure, and we found that after only one season of growing cover crops, there was a significantly better score for soil structure under the cover compared to the bare soil. We also found, unsurprisingly, that having cover crops decreases the number of weeds in your field compared to bare soil, as having something growing, covering your soil, is obviously going to smother the weed growth.